Hi, I'm JOON from Group 2. So today I'll be talking about the introduction. Now, the rubber industry has been slowly but surely establishing itself as an economical and significant industry, mainly because they are low in cost, have high water resistance and elasticity, making them very stretchable, and they do not disintegrate easily as they have a high hardness value. Now, this production process of rubber uses large amounts of water as well as chemicals and utilities, and then eventually produces undesirable side products such as waste and effluents. Now, these effluents have high amounts of wash water, carbohydrates, proteins, lipids, salts, and latex. Now, approximately 14.1% of industrial water pollution was caused by rubber industries, which is not desired. Therefore, it is essential to treat this effluent, as untreated effluent leads to negative and long-lasting impacts to the environment.
Hi, so I'll be going over on the details of the processes. So rubber is the main raw material that has been used in tire manufacturing, and it uses both natural and synthetic rubber. To produce raw rubber used in manufacturing of tires, liquid latex is usually mixed with a form of acid that causes the rubber to solidify. So generally it undergoes 4 different processes to manufacture our tire. Firstly, it's by blending, milling, building, and followed by curing. So in blending, there are over 30 types of materials used that are mixed in a giant blender, and it is usually done in batches. This is done to create a black gummy compound, and the main function of this stage is actually to break down the rubber bale, fillers, and chemicals and mix them with other ingredients at temperatures as high as 160 to 170 degrees Celsius. And to prevent any damages, mixing is done in 2 stages, and at the final mixing stage, curative package is added, and the final mixing temperature should not exceed 100 to 110 degrees Celsius to prevent scorching from happening. So once mixing is complete, the batch is then dumped out of the mixer and left to cool. It is then gone through powerful rolling mills that cut into thick strips to form the basic structure of the tire. So for the building stage, this is the stage where the components are built from inside out, and things like the textile elements, steel belts, beads, ply, thread, and other components are placed in a tire building machine. And at this stage, the unfinished product is actually labeled as green tire. So during this stage, the green tire is vulcanized in hot molds with a curing machine to compress all the different parts of the tires together and giving it the final product its final shape and form. And the purpose of curing is actually to harden the green tire by heating it with steam or electricity at a certain temperature. And once curing is completed, the tire is then removed from the mold and is left to cool.
Hi, my name is Biao, and today I'd like to present about effluent characterization for the raw natural rubber industry. In the raw natural rubber industry, wastewater mainly comes from 3 sources, which are wash water, uncoagulated latex, and lastly serum with small amounts of proteins, salts, and lipids. After conducting literature review, we have found the typical range of levels for main pollutants in raw natural rubber wastewater. After that, we have proceeded to compare with the discharge limits in the Environmental Quality Regulations 1978, which is for the raw natural rubber industry. And the highlighted values indicate that these pollutants have exceeded the limit. And the main issues for raw natural rubber effluents are pH, BOD, COD, TSS, and total nitrogen. Wastewater from the natural rubber industry could lead to serious environmental harm if not treated properly. There are 3 major potential impacts identified in this project. The first one is eutrophication due to the high levels of ammoniacal nitrogen in natural rubber wastewater. Secondly, high levels of sulfates in the wastewater will lead to scale build-up in water pipes and also cause water to taste bitter. Lastly, hydrogen sulfide is also largely present in raw natural rubber wastewater. Generally, the impacts that it causes are mild odor and lower organics removal efficiency.
A very good day. I am SARANEE NAYAHI. I will be presenting on laws and regulations followed in Malaysian rubber industry. Malaysian rubber industry generates a significant amount of effluent. These wastes are subjected to various regulations under the Malaysian Environmental Quality Act 1974. EQA 1974 is the principal legal instrument to control water pollution in Malaysia. This table shows the maximum allowable standard limit for effluent discharge into wastewater for the rubber industry. The rubber industry should comply to the Environmental Quality Prescribed Premises Raw Natural Rubber Regulations 1978. This regulation ensures that all the effluents from rubber product manufacturing factories in Malaysia are treated and meets the legal discharge standard before they are allowed to be discharged to the environment. Hence, this table in this slide shows the parameter limits for water-course discharge of effluent from prescribed premises for the production of concentrated latex or its associated product. This slide further shows another regulation which should be followed by the rubber industry. The effluent discharged from rubber industry, as for this project, specifically tire industry, should also comply to the parameters set by Environmental Quality Industrial Effluent Regulations 2009. This regulation covers the acceptable conditions for discharge of industrial effluent, which is categorized as Standard A and Standard B. Standard A is applicable to discharges into any inland waters within catchment area, while Standard B is applicable to any other inland waters. Thus, this concludes the laws and regulation which should be followed by the rubber industry. Thank you.
Hi, my name is ZHEN, and I will be presenting on the proposal treatment system for the effluent from the rubber tire industry. Generally, for the treatment of wastewater from rubber processing industries, conventional pond systems that consist of aerated, anaerobic, and facultative ponds are usually used. However, these systems have been found to be disadvantageous, as they not only require long retention times and large treatment areas, conventional treatment methods also consume a lot of power during aeration and sludge discharging processes while causing environmental pollution through emissions of greenhouse gases and groundwater pollution. Hence, the proposed treatment strategy for the wastewater generated is to utilize an upflow anaerobic sludge blanket reactor coupled with a downflow hanging sponge, collectively known as a UASB-DHS system. The functionality of each unit displayed in this figure will be discussed next. First and foremost, the wastewater from rubber tire manufacturing plants will be fed into an equalization tank, which serves to overcome operational issues by stabilizing the flow rate of the incoming wastewater, in addition to improving performance of downstream processes and reducing size and cost of downstream treatment facilities. Next, the wastewater with steady flow rate enters the UASB reactor, which is responsible for breaking down biodegradable organic matter. During the process, methane is produced and recovered as biogas to be used as energy source. After that, the wastewater passes through a downflow hanging sponge, which utilizes oxygen to break down organic contaminants and pollutants such as nitrogen and phosphorus. It should be noted that the DHS can operate under conditions that require little to no aeration due to oxygen being readily dissolved in the wastewater. Last but not least, the treated wastewater enters a settling tank where sedimentation takes place. Sedimentation refers to settling of suspended particles present in the wastewater for purification purposes. The sedimented particles form a sludge at the bottom of the tank, which is removed periodically. The removed sludge can be used as agricultural fertilizer, while the final effluent can be disposed after ensuring that it meets environmental regulations. That's all for the wastewater treatment proposal part. I will now pass the floor to the next speaker. Thank you.
My name is NAGAAMMAI and today I will be presenting on the design of upflow anaerobic sludge blanket UASB unit. Under this chapter, there are two subtopics, which is design criteria of USB reactor and sample calculation for USB reactor. The next slide is the design criteria for the USB reactor. There are three main criteria for the first is COD loading. In a rubber industry, normally the COD loading is high strength, which is around 100 to 1000 mg per liter. Next is the shape of reactor. The first is circular shape and the other is rectangular. The circular shape is normally used if the reactor volume is less than 300 meter cube, and the rectangular shape is normally used in industry. Next is the design operation. According to DOD guidelines, the surface overflow SOR is less than 20 meter cube at average flow and around 36 meter cube at peak flow. The liquid upflow velocity is less than 0.9 meter per hour. Height of reactor is more than 4 meter. This is to accommodate the sludge bed, sludge blanket, and gas liquid separator. And the bed height is around 1.5 meter to 2.5 meter. Next is the sample calculation. This is the assumptions of flow of USB reactor obtained from a literature review. The feed suspended solid is 250 ppm. Efficiency is around 80% removal. Influent flow Q is 2.94 times 10 to the power 6. Solid content in feed is around 3%. The calculations were done based on the method taught in class using the assumption, and the sludge generated obtained per day is 588 kg in a rubber industry. That is the estimation. Alright, that's all. Thank you.
So, I'll be concluding the presentation today. As we know, rubber industries have been increasingly important to our daily life, having a number of advantages over other materials, such as having high resistance, good textile strength, and also tear resistance. To produce rubber, or more specifically tires, there are several lengthy and complicated chemical processes involved, which are blending, milling, building, and curing. Now, large quantities of effluent up to 410,000 liters of effluent are being produced or discharged per day to nearby rivers and streams to be able to just produce just 20 tons of rubber products. So, effluent treatments must be implemented in order to avoid the negative consequences of effluent discharge. In our proposed effluent treatment, several units and equipment are deployed, such as equalization tank, upflow anaerobic sludge blanket UASB reactor, settling tank, and a downflow hanging sponge DHS. Despite the necessity of rubber production processes, side products or effluent produced by the processes involved can be harmful towards the environment. Therefore, a proper effluent treatment system must be designed and implemented in order to produce rubber in a responsible and environmental friendly manner. That's all from Group 5. Thank you.